The flames in a building fire can reach temperatures of 1,000 degrees Celsius or more. That's as hot as inside a volcano. Fire-resistant glazing must be able to withstand such enormous energies without bursting. Just a few centimeters can protect escape routes and thereby save lives.
Fire-resistant glazing consists of 2 sheets of insulating glass, with a gap between them filled by a layer of fire-resistant gel. Standard systems use a hydrogel containing acrylamide, which is toxic. Our gel, by contrast, does not contain any toxic ingredients.
Hörmann discovered this new hydrogel formula with the help of researchers from the Fraunhofer Institute for Environmental, Safety and Energy Technology, UMSICHT. Together, they completely rethought the problem of how to produce fire-resistant glazing.
In the event of a fire, the pane of glass exposed to the flames bursts, thereby releasing the protective gel. Under the influence of heat, water then evaporates from this hydrogel. This causes a salt crust to form on the surface of the gel. Our aim was to identify a gelling agent that would provide an alternative to acrylamide.
What the researchers found was a real surprise. The answer lay in a basic component that received opinion told them shouldn't work. In fact, the correct and top-secret combination of components turned conventional wisdom on its head.
Even as we were developing it, we already felt pretty confident about the gelling agent, so we decided to go straight ahead with a fire test. Within just a few minutes of being exposed to the flames, the inner pane of glass burst with a huge crash. My initial reaction was, okay, back to the drawing board. But in the end, the glazing came through the scheduled 30-minute fire test without any further damage. You've got a temperature of 1,000 degrees on one side and a tenth of that on the other, with a mere 30 millimeters in between.
The new formula was only the first step, and each advance brought new and unexpected challenges.
In principle, the entire production technology has been designed and developed from scratch. You can say that we really did test and improve, discarding old ideas and bringing in new ones.
Even a flat tire sustained on a cycling tour provided inspiration for a new type of valve that is about to be patented. With such ingenuity and Hörmann as the driving force, the new system was ready for production in just 4 years, a record time compared to the 10 to 12 years usually required.
We now produce our own glass in a shorter time and in a very resource-efficient way, without putting anyone in danger.
The new Vitrifier fire-resistant glazing is now being used for the renovation of the Global Tower and construction of the Grand Tower, both in Frankfurt. It will help improve safety in the event of a fire and provide testimony to the power of lateral thinking.